Earth science, our topic today is sedimentary rocks. So in the reference table that you have, you will be looking at page number 7 here. Pardon the shadows from the camera and my hands. Where I'm recording, the lighting is not the best. But if we take a look at sedimentary rocks, one thing I want you to notice about this table here that's given to you in the reference is that we have earth science. Our topic today is sedimentary rocks. In this reference table, your scheme for sedimentary rocks is going to be found on page number 7. Pardon the shadow from the camera where I'm recording today. The lighting is not the best, but we'll manage. We have them divided into 2 different categories, well, actually 3. So I want you to take a look at them. We have clastic, it says fragmental, crystalline, then we have bioclastic down here, and then we have one that says that it's either crystalline or bioclastic. So we'll come back to these in just a second. The clastic sedimentary rocks, these are ones that are formed from pieces. In fact, clast as a word is an old Latin word that means piece. So clastic means pieces. So where do the pieces come from? You probably already know. But let's just draw it anyway. Simple version of this. We have igneous rocks formed from volcanoes. So you probably know now that we have our intrusive igneous are formed inside by the cooling of magma. Extrusive igneous rocks come out of the volcano and cool quickly. Of course, that's not the end of the story. Mr. Cloud here, I'll have something to say about that. So whether it's intrusive or extrusive, the potential for what we call weathering or the breakdown of rock exists. So fast forward in time, little pieces of rock are going to break off. And we call those pieces sediments. You might call them rocks, you might call them stones, you might call them, pebbles or sand. We actually have a bunch of different kinds of sediments, and we classify them by how big they are. More on that in a moment. Once you break rock down into small pieces, they can be carried away. And so picture rain washing these into a stream, and the stream taking them far away. How sedimentary rock is formed, just as a stream will carry them as long as it has energy to do so. But then eventually it'll get to what we call a low energy environment, or what we call a depositional environment. So think about like the ocean or a lake. So streams coming down, strong enough to carry this little sediment right here. Then it hits this low energy environment and it drops it and falls to the bottom. Now this might repeat over and over and over again for a long time. So long that maybe even the lake goes away. We'll find out more about how that could happen when we do plate tectonics. But let's picture the lake's gone now. But we still have all of these little sediments stacked on top of each other. These little pieces. Well, as they keep getting stacked on top of each other, they get compressed. We call this compacted. And then groundwater actually starts to flow through there and creates a type of cement that actually holds them together, holds the pieces together. So we say compacted and cemented together. Eventually, you have a rock that is composed of all of these sediments or pieces. And those are the ones that are made out of pieces that we call clastic. These are our clastic rocks. We have conglomerate, breccia, sandstone, siltstone, and shale. Now these are classified by the size of the particle that makes them up. So you'll notice right here that we have grain sizes. And they're arranged from the largest to the smallest. So the biggest sizes we have are pebbles, cobbles, and or boulders. In fact, boulders are your biggest stone you can call sediment. I think you guys can picture what a boulder looks like. A cobble is a rock that's about the size of picture something like about the size of a softball to a volleyball. That's a cobble. And pebbles, I think you've seen pebbles before on a beach or whatever, but they're like, marble size, a little bit smaller sometimes. But that's a pebble. If we have smaller pieces than that, we typically classify them as sand. Now, we needed some definition, some parameter for this. What we did is we said, scientists said that sand is 0.006 centimeters to 0.02 centimeters. If you are that size, you are a piece of sand. In fact, you can't be anything else if you're that size. We're just going to call you sand. And silt is smaller than that, 0.0004 to 0.006 centimeters. And then clay, even smaller than that. Students can picture clay because they have interacted with it at some point in their life, but usually as children. But silt's a tough one. A lot of kids don't know what it is. So silt, you'll find, if you guys ever take your foot and you go up to a mud puddle that's really, really still, and you press on it and you watch all that little cloudy stuff come up, a lot of that is about silt size. We're talking about really, really small stuff. But if we compact those things together, these things, if you compact them together, you get these corresponding rocks. You get conglomerate and breccia if they're pebbles, cobbles, or boulders. The only difference between these is that conglomerate has rounded fragments and breccia has angular ones. Sand, you compress it together, you get sandstone. Silt, you compress it together, you get siltstone. Clay, you press it together, you get claystone. Oh, no, we don't. We get shale. Good thing for you guys is you've seen a lot of shale in your life, so you probably can picture what it looks like. But I did want to show you some of these clastic rocks while we're talking about them before we go on to the other ones. So conglomerate, I have a piece right here. I found this in the Allegheny National Forest. And you'll see that really, pardon this, just a piece of tape. Can't get it off right now. But you can see that we have individual pebbles, rounded pebbles, cemented together. This is just one rock. These pebbles probably came from an environment that was a stream or a beach, probably a pretty ancient one, because where I found this, the area was not impacted by the glaciers. So these were moved from something, maybe a previous glaciation or something, moved them from their environment to a different environment where they were compacted and cemented together. And I found them really pretty much on top of a big hill in Allegheny. So this is conglomerate. I can see the grains, we call it visible grains. I can look at them and I can see them. And that's going to be an important phrase for clastic sedimentary rocks. Got a couple pieces of sandstone here. You can see grains of sand in it. I mean,